You get paid when you ship stuff. So that's always the challenge for people that make stuff. There's always been that sort of gap. And so that's kind of what we wanted to explore today is what are the sides of that gap and how do we fill it in?
Almost every application you can think of wants to bring AI to the edge. It doesn't matter what it is. Edge AI is on fire.
You have to really look ahead and look around the corner and make some big bets.
We are at a moment in time where I call it the Netflix moment. The hardware is there. And people are trying to figure out, how do I build the killer app?
We are living in a world which is all of a sudden starting to expand in such a rapid rate. I don't think hardware or software are ready.
How do you all better align hardware and software? How do we close this gap?
I'll let Rajesh go first.
That's the only way I see this going.
Till then, this is going to be a chaos.
Welcome to the Edge of Tomorrow, the Edge AI Debate, a spin-off series of the IoT Podcast brought to you in collaboration with the Edge AI Foundation. We're bringing together some of the brightest minds in Edge AI and beyond for discussions on the most pressing challenges and opportunities shaping the future of AI at the edge. This isn't just another AI podcast. Every episode cuts to the core of the technology we're building and the path we're on, offering diverse perspectives and hard-hitting analysis, and the kind of conversations that leave you questioning everything you thought you knew about Edge AI. This episode is brought to you by the Edge AI Foundation, a global community of innovators, researchers, and industry leaders working to make Edge AI more accessible, sustainable, and impactful for the real world. At Edge AI Foundation, we believe the future of AI isn't just in the cloud, it's at the edge. We're focused on building and scaling intelligence where it matters most, in the devices, sensors, and systems powering our everyday lives. And coming up this July, we're hosting Edge AI Milan 2025, a global gathering of product leaders, technologists, founders, and Fortune 500 decision makers. To learn more or register, visit milan2025.edgeaifoundation.org. Now let's dive into the show. All right, we are here for the IoT Podcast. I am your host, Pete Bernard, CEO of the Edge AI Foundation, and have two special guests here today that I know very well, and it's great to see them virtually. I actually saw Rajesh. I think I saw you, was it like a week ago in the Bay Area? And then Reza, I think, was it in Taipei? I think I saw you.
Yeah.
Last. Yeah. So,
4 weeks ago, yeah.
We're all jetting around. So yeah, why don't you guys introduce yourselves and your company, and then we'll get into the hot topic of the day, the debate on commercialization and deployment for Edge AI and how do we go faster and farther. But why don't you get started with some introductions first? Rajesh, do you want to kick it off?
Thank you, Pete, for setting this up. My name is Rajesh Subramaniam. I'm CEO and founder of EmbedUR Systems. We've been building embedded software for our customers for the last 20 years and continuing to grow. And this is an exciting space that we are getting involved in.
My name is Reza Kazerounian. I'm founder and president of Alif Semiconductor, a startup which is almost 6 years old, specializing in embedded systems, controllers, with a specialty in the edge AI and endpoint AI.
Yeah, and actually the last time I saw both of you was kind of like, it was interesting. There were some themes there around this topic today, because I think, well, when I saw Rajesh, you were giving a talk to the AI Foundry organization there in the East Bay, and talking about kind of the history of EmbedUR and how you've built up this, expertise over time of helping companies get to market, frankly, I always say, call it doing the dirty work, but, kind of, getting the software written and deployed and all the bugs cleaned up and just developing the stuff that's needed to really commercialize. And then I think, Reza, when I was in Taipei, you were there at the show. The show, for anyone who's not been to Computex, I encourage you to go because it's insane. It's like I call it the hardware supply chain for AI. It was like bumper to bumper, shoulder to shoulder. I felt like a pinball on the show floor being bounced around. There's so many people, and it's all about building tech. They're building tech, not only the chips and the software, but people are building like cooling systems and like rack handles for servers and like, dolly wheels for server cabinets. I mean, everything is being manufactured there, but the as we know, there's a gap between making stuff and then like shipping stuff, right? And this is kind of like where I think EmbedUR and Rajesh's companies come in to like get people to ship stuff. And then, Reza, you're kind of on the making stuff side, right? And so in Computex, I felt like there's this gap, between making stuff and shipping stuff. And as we all know, you get paid when you ship stuff. So that's always the challenge for people that make stuff, right? And I worked at Microsoft for a long time. We used to get these Ship It awards where when the code went to GA, you'd get a little square that you would stick on your, little trophy in your office that said that you shipped something. But to be honest with you, like just because you went GA didn't mean that anyone was using the product, It was just sort of an internal milestone. So there's always been that sort of gap. And so that's kind of what we wanted to explore today is, what are the sides of that gap and how do we fill it in? Maybe why don't we start, Reza, since you're on the maker side, you make tech and Alif is some of the coolest edge AI tech out there. What are you seeing like, and how have things changed on the maker side in terms of getting products to market? Like, what are you seeing like as things that are really enabling you to do that, or maybe points of friction on the tech maker side?
Well, good question. And, honestly, to answer that question, I'm going to kind of limit my view, at least for this podcast, to anything which is related to edge AI and endpoint AI, which is really, I guess, the main topic, right? So when I started Alif about 6 years ago, it was a completely different market with a different set of expectations. I'm just looking at the days. If you go back to 2018 or 2019, the large language models, they're running up 10 to 50 to 100 maximum million parameters, correct?
Sure.
5 years later, they're running on getting close to almost 1 billion parameters and exceeding.
Oh, yeah.
We see how GPTs and Llama and everything is evolving. In my world, the speed by which things are accelerating is even stronger. When we look at the endpoint or edge AI devices, all of a sudden, almost every application you can think of wants to bring AI to the endpoint or AI to the edge. It doesn't matter what it is. It's in transportation, automotive, it's in healthcare management, it's in robotics, smart city. People are coming with ideas which was not realizable about 5 or 6 years ago. And all of a sudden, there's an explosion of ideas, which is, as you said at the beginning of your call, edge AI is on fire. The problem is, how the product has to change to be able to enable that. And this is where I think the challenge and the difficulty is how the products that we did 5 years ago are going to look different than the product that we do next year. And that is where all our focus and attention is going. That's where we see the difficulty of the development and creation of the next generation of the hardware to satisfy the demand. And that is where my world is. That's where I spend most of my time. And that's where I see the challenges and the rewards.
Right. So I think on the tech maker side, especially in the semiconductor space, I mean, maybe some people realize that it's like a long lead. It's a long lead process. So in a world where expectations are changing very quickly and people are bringing all kinds of crazy ideas that they want to ship to market, being able to make the tech that's going to power those ideas, you have to really kind of look ahead and look around the corner and make some big bets. And so that's probably something that's changed whereas like maybe 5 years ago, I think we kind of knew like the space kind of pre ChatGPT was fairly well-defined space of, anomaly detection and AI vision and things. And we had a thing. And then all of a sudden there was this explosion or Cambrian explosion of AI with multi-billion point models where people now want to do all kinds of crazy stuff. So I can imagine like that's one of the challenges right now is on the tech maker side where you need, a couple of years to incubate and develop and deploy. It's hard to predict, how do you build stuff that's going to be, hit the sweet spot at the right time. And I guess Rajesh on your side, and I'm trying to do this on size, even though I know we're all on the same side, but, the premise of the show is that it's a debate, but, we're not really debating here. Is, So you work with a lot of folks that are making this incredible tech, and you guys make great tech as well. Like, how do you think about, or maybe how things have changed in the past, maybe since the ChatGPT moment, for you in the embedded sort of edge IoT world, where you're trying to, commercialize and get people to market? What's changed for you in that space?
It's crazy, right? I mean, again, as Reza said, go back to 2018 and look back to things that we were doing back then. And now fast forward, all of a sudden, we're now talking to customers. I had one customer who called us and they designed one of their products. It's a set-top box. And they put it in an AI accelerator and they just selected a chip and designed it in, right? And now they're calling us to ask us, hey, we have an AI accelerator. How can we use this AI accelerator? It's almost like, people are designing things in because they want the cool word AI around the product. And then they are like trying to figure out, hey, how do I use this? My point being, it's almost we are at a moment in time where I call it the Netflix moment. Back in 2000, we were building multi-service provisioning platforms that was lighting up Sonnet and Ethernet networks at 10 gig, right? But then there was no killer app. And the box didn't add any value back then because we didn't have a killer app like Netflix. But the hardware is already there, right? So fast forward, I'm seeing the same thing play out now in 2024 and 2025. The hardware is there. And people are trying to figure out, how do I build the killer app that can exploit artificial intelligence and models running on my AI accelerator at the edge? So it's pretty cool. Some customers are designing it in and then asking us how to build applications around it. Other customers are like asking us, hey, we want to design this in. What is the best edge device to choose? Is it a GPU? Is it a CPU? Is it an MCU? Is it a... So it's interesting what's happening.
I mean, it's almost like to the point we're talking about with Reza and like designing hardware, you have to almost and I say overspec it, but you have to put in a lot of stuff because you're not quite sure exactly what people are going to use and how they're going to use it. And then, and quite often, you could be shipping, designing hardware platforms that have an NPU in it and you're not exactly sure what you're going to do with it.
Exactly.
Whereas, back in the good old days, especially way back, you would say, even before the edge AI days, you would say, well, I'm building this, industrial thing and it needs to do X, Y, and Z. And I'm going to spec the capabilities down to the semiconductor level to do that function and, keep the costs low and all that stuff. And now it feels like these devices it's almost like there's some speculative design to add in some capabilities that you're not quite sure what you're going to do with yet.
I mean, just to pick up on that, I think that's really, when we look at the edge AI and endpoint AI and look at the challenge, like honestly, that is where the challenge is, because unlike the big AI, which runs on, which runs ChatGPT, Llama and the rest, when you look at the edge AI, we're looking at such a wide spectrum of application and use cases with a completely different set of requirements. Devices that need to run on a battery, devices that don't need to run on a battery. Devices that have a very small footprint, devices can be the bigger footprint. Devices that may require, 1 tera ops of NPU capability. Devices may only need 100K of GOPS of NPU capability. Memory size could be X or it could be very large, 1 gig memory just to fit the model in. So it's almost impossible to come with one hardware that can satisfy everything. So as a result, you need to have a whole range of hardware that can satisfy hundreds of different applications and use cases. And that challenge is now all of a sudden starting to explode to become bigger and bigger because the use cases themselves are getting bigger and bigger and bigger, which means different hardware, different software optimizations, different models, different algorithms. So we are living in a world which is all of a sudden starting to expand in such a rapid way, which I don't think either hardware or software are ready to yet service that world. But it is very exciting because that means opportunity is starting to explode. So
yeah. Well, it used to be that hardware and software cycles were kind of in sync, right? Where 12 to 18 months to sort of build a hardware platform. Your software was kind of on an annual life cycle ish, so you kind of line it up. Now it feels like on the AI side, like new models are being introduced on like a monthly basis that are more and more efficient. and new applications and use cases. And we're still in sort of the 12 to 18 month hardware cycle, so now it's like, that's kind of one of the big challenges, right? Is like when you go to deploy and commercialize this thing, the specs could change. I mean, I remember I was at a aerospace conference recently and talking to some satellite designers, or I don't know, they're building rocket ships or something. And they have like a 10-year plan, to build this thing. And they've said, oh, we've had to restart like twice now because 2 years into it, everything is obsolete and we have to start over again. And they were trying to figure out how to solve that problem of having to restart every 2 years. And so I said, well, you probably just need like a 2-year plan as opposed to a 10-year plan. Then you don't have to restart every 2 years. But, it's like, that's one of the challenges, I think, is when the software starts to get into this, hyper cycle of change. How do you better align hardware and software? I don't know. Any ideas on how do we close this gap?
I'll let Rajesh go first. I have
okay. Wow. How do we close this gap? See, again, it's going to be, it's very interesting to see that now we have models that can run on edge devices. And everybody thinks that once you have a model, you just download the model and everything works right off the bat, right? But the issue is model accuracy is the biggest challenge. And the model accuracy is only as good as the data that's curated, right? So essentially establishing some sort of software engineering processes around this whole ecosystem of, okay, I have a model, I have the toolkit, I have everything lined up, and I have spec'd out a clear process. That's the only way we can stay in sync with hardware developments that are going on. And right now, it's a mad rush to say, okay, let's go build something and provide a proof of concept with models running on the edge. But that doesn't stop there, because there's a lot more to it. Securing your models, aligning software engineering processes, making sure the accuracy of the model is good, and then finally locking it in and making it adaptable so you can constantly change based on what you've learned. So once we establish a process around it, that's what we're working with our customers on. Make it easy for them, create a process around it, dumb it down so it becomes transparent to them. And way you make engineering software development cycles shorter. That's the only way I see this going.
True. Yeah. I guess that would be one way to solve it, is to make those cycles shorter. Like you have the Model Nova initiative and other things. And, maybe people don't realize that, again, back in the good old days, Reza would make a really cool chip, and then someone would port an RTOS to it and ship it. And now it's like, no, that's just the beginning. It's like, once the chip is done, or even mostly done, then it's like, well, you need to get your data sets together. You need to get your model trained. You need to get things deployed. Like you said, it needs to reinforcement learning, model drift. Like there's a whole life cycle of software that happens operationally in the edge AI space that didn't happen in previous kind of embedded systems and IoT systems, right?
I think, just to maybe pick up on that, Pete, and you're kind of right. I mean, the example you gave in back in the old days, there was a chip and an RTOS, and then they would put in the market, the customer would pick up and do something with it, right? But AI, especially endpoint and edge AI, is changing everything for a couple of reasons. And to me, the answer to your question is how to close this cycle is standardization. Things have to become more and more standardized. What do I mean by that? So in the old days, if you look at the last 20 years, embedded devices were evolving like this. A bit more clock rates, a bit more memory, a bit more IOs, more capability to run a bit of software, but things were evolving like this. Endpoint AI and edge AI are requiring these things to start to evolve like this. The problem is the application spectrum is completely fragmented and very wide. If you wear a smartwatch or a health tracker device for health management, you have a set of requirements from a hardware point of view and the software. Footprint, battery consumption, yet capability to run a good amount of model work on it. Looking at a robot, completely different set of expectations. If you're looking at an automotive and autonomous driving, which needs to do image captures, image classification, safety management. You're looking at a completely different set of constraints. So the constraints are very wide. And to me, the only way to create a system that works and enables people to be able to evolve their applications is creating proper standards, both on the hardware side and the software side. What it means from a hardware point of view is rather than having a single point device which can do tab A and then have to create a whole brand new device which can do task B, you create a platform. The platform has to be scalable. And then based on the use case, you can choose one of the devices within the platform, but the software, the architecture of the device and the ability to run a software on it should be uniformly the same to facilitate the software people to be able to develop a model, to train it, optimize it, and eventually turn bare metal on code into a device. Today, we don't have that standardization in the marketplace. Different hardware suppliers have their own architecture, which requires which basically means they have their own NPU architecture or the other type of neural network engine, which means they need to have the proprietary tool chain, which means the user have to learn how that thing works before they can actually do the software work. And the knowledge in the customer base for anybody from somebody who wants to make a bicycle smarter to somebody who wants to make a robot smarter or to somebody who wants to make a health device smarter. The knowledge base to develop this algorithm is not there. So people either start from the public libraries or they start going to entities like Rajesh has to be able to do the task for them. So things are so spread. The more standards we create, standard hardware, standard software languages, and then the ability to be able to put it together. Till then, this is going to be a chaos, in my opinion. And
Great point, because that was the reason we introduced Model Nova. And Model Nova is like the tiny model zoo. Today, we have 75 models, and they're open source models. And the goal is to get 150 models by the end of the year. And today, you can choose a Raspberry Pi platform and try out any of these models. And there's model accuracy, benchmark, everything's available. And what I'm excited about is, to Reza's point, in Milan, we are going to launch our Model Nova Fusion Studio. So this is going to be a key tool that designers can bring in their own data, train it using the studio, and actually retrain, bring in their own parameters. And then we are going to allow them to select a bunch of silicon partner chipsets that we'll partner with. So you can do it on an ST, you can do it on Infineon, you probably do it on a multiple range of devices. So that is the goal. So hopefully the idea being that becomes a standard and we can help our customer deploy these models faster.
So one of the things I think we're identifying is in that gap that I talked about, that, the way to shorten that gap is through standardization and through more complete tool chains and tool sets that get people sort of 80% there, kind of almost out of the box. Now it's interesting. So in the, traditionally software folks like myself would always love standardization because we want all the hardware to look the same, right? Because we just write software and we don't want to be bothered. But people on the hardware side, and I've never met an NPU architect that has disagreed with me on this. Hardware folks don't want standardization because they want differentiation. They don't want to be commoditized, because if you talk to one NPU architect, their design is awesome. And then if you talk to this other NPU architect, their design is even more awesome. So you can't stop NPU architects from architecting cool things that are non-standard because it's better. And so part of it too is like there is this building a better mousetrap thing happening out there in the edge AI space where people are still innovating, and they're still designing things that are better, quote unquote, even though they may be non-standard. So that's another tension point to resolve, is like in the early days, let's say I think we're in the steam engine era of edge AI or AI in general, right? So we're still early. How do you still enable people to innovate? And isn't standardization stifling innovation to a certain extent?
I think, it's a very good question. I mean, you cannot stop people from innovating, but at the end of the day, we are all in the business of making money. Without money, we cannot pay our expenses.
That's
correct?
true.
So there got to be a very kind of close loop between innovation and return on the investment, correct? I can clearly see when we talk about a big AI, which is going to run on data warehouses with hundreds of servers.
Sure. Nuclear powered multi-tenant data center.
Every little detail matters because you have to worry about. So that's where I can see NPU innovation becomes really important, because thousands of data scientists working on the same topic going there. But when you look at the endpoint or edge AI, when you're talking about tens of thousands of applications to be developed with completely different people who have no connections with each other, that is becoming a hindrance. It's kind of like, I always give an example. The only reason that we have cars and the cars run on their own is because all the cars have 4 tires. Everybody knows how to drive. The signals are the same. Everything is standardized. So we have made the system to work. When you create multiple different MPUs, which have to be embedded inside an embedded system, which, by the way, inside an embedded system, MPU is probably 1 out of 50 different elements. You have memory, you need to have IOs, you need to have digital analog interfaces, you need to have the CPU, you need to have a bus structure, architecture, and everything else. To make that thing proprietary, all of a sudden you create a whole different set of issues for whoever wants to create their application running on that MPU along with everything else. And they are 1 out of 10,000 other users. That is where the problem all of a sudden explodes. So it depends on what side of the fence you are. But for me, I think in the embedded world, we kind of went through that route 20, 30 years ago. If you remember, if you look at all the players in the marketplace, Motorola's and Zylogs, and eventually, they disappeared, and now it's DNXP, Aleph. Everybody used to have a proprietary MCU, MPU core. Over 20 years, the market evolved to a more standard core, more standard tool chain and tool frame, which is third party, because that is the only way the market figured out they can evolve. I think we're going to go through the same thing here with the MPU in the next 5 to 10 years. And eventually, maybe there's going to be 1 or 2 MPU architectures. And the tool chain is becoming the most critical issue, because the framework of the tool chain has to enable everybody. And the tool chain is going to be, again, 1 or 2. So the standardization is going to happen by force. Innovation will be kind of lost in capability to use the product.
True. I mean, it's, you're seeing this too in sort of the mergers and acquisitions happening in the semiconductor space, right? I mean, this past week we saw Nordic buying Neutron tool chain, Qualcomm buying Edge Impulse, NXP buying Canara. I mean, although that was a chip company, but the chip companies, semiconductor companies, and, Reza, you're in the bucket there, chip person, are kind of going up the stack a little bit and saying we need the tool chain to be there to make sure that we can snap into these kind of deployment, mechanisms, right? So that people don't have to start from scratch when they buy our chip, that we have a tool chain that can play nice with MLOps systems and other things. So yeah, there's something in there for sure. I mean, the other thing is, like, where does the standardization occur in the stack, right? Is it at the MPU architecture, or do we say, well, as long as you have like a tool chain that makes all the models kind of play nice up here, and you have an MLOps system, then we're good. I think that's kind of the story to be told, is like where in the stack does the standardization occur, and to maintain that differentiation. I don't know.
Yeah, I mean, if you think, right, we've already kind of gone towards a direction of almost all semiconductor edge devices today can run a model. So we have standardized on one thing. Oh, we have edge, we have model. That's already that. But if everybody were to license ARM core rather than having to build sophisticated NPUs, and if we can build an architecture around it, and that's what we believe firmly on. If we can, we chose Raspberry Pi because of ARM, right? And for us to now scale those models rapidly to the other ARM core architectures is very, very easy, because it's not a process.
Yeah.
So once we create that environment and that framework, then it becomes easy to adopt, and then create structures around it. Then you have something that you can take to market very quickly.
True. Yeah, no, and I think that definitely is an accelerant to the market. And I think what ARM is doing with Ethos and things like that is definitely going to be accelerating the market. But counterpoint, since this is a debate, this is a debate show. What about spiking neural networks and neuromorphic computing, where we're re-architecting the chip to fit the model, as opposed to trying to get the model to fit kind of the existing compute architecture? Like, where does that fit in this standardization thing?
But I think that's really where, it's a good question. And I think that's where the line has to be drawn. I gave an example of the big AI versus the embedded AI. Mm-hmm. Embedded AI has to satisfy a very fragmented world and a fragmented set of applications. Where the big AI is about optimization, capability, performance, power, and everything else. I think we will see, and there should be innovation for the big AI, because we're talking about super powerful, massive chips with teraops of capability to run NPU, and every ounce of performance optimization, which has a lot of dependence on the architecture, matters. But when you look at the endpoint or edge AI, where you have an integrated set of functions that have all come together in one silicon, which NPU is only one out of 50 elements, it's a completely different world. And that is where the tools will be separated. In the fragmented mass market endpoint edge AI applications, standardization all the way from the NPU architecture to the tool chain to the tool frame, and eventually the models and everything becomes super critical, because you're dealing with tens of thousands of customers with different use cases. While on the other side is all about optimization, which becomes a whole different world. And I think that is really where I see it. So when I see, today we see this trend that people want to take SLMs, which usually prune down from LLMs, and they want to optimize it for the edge. For those SLMs to work at the edge, and Rajesh knows this very well, they gotta be super optimized.
Yeah.
Because there's a lot of constraints. There's memory constraints. Sure. It makes a huge difference if you need to put a 256 or a 1 gig memory there that has to run this model. But that model on that memory has to interact with the CPU and an NPU next to it on a separate chip. Mm-hmm. The interaction between the two becomes important because the matter of power consumption, size, cost, and everything else. So when we go to that world, all of a sudden, a standardization becomes super critical. When we are on the other world, the big AI world is a completely different way to look at it. And you're absolutely right. It's all about the hyperscale architectures, all about, NPU performance, NPU capability. So in my world, it's all about the standardization. And I think if that standardization is not achieved, we make the life of the user much more difficult than it should be.
Yeah. And the way we look at it, right? There's the world of abundance, which is you have serious compute, you have a lot of memory, you can do whatever you want, run huge models that doesn't have to be even 96% accurate, because big deal at times, like your conversational models, CLMs may not give you the right answer. So it's okay. But then we are in the world that we operate in. So we have to bring models, which is common. We'll get the models onto small devices. But like Reza said, optimizing it for memory, because data transfers account for major portion of the power consumption, right? And then being able to operate in a resource-constrained environment. Optimize. This is where you can standardize the rest of the stuff. But then if you can create stickiness for our customer by creating optimization and leveraging all the resources to the maximum, meaning make sure you squeeze every ounce of that CPU and make sure that you are extremely conscious about consuming power. These are the differentiations at the end of the day that makes, like, for example, Alif's customer sticky, right? If we can make that part efficient, the embedded piece of it efficient, while standardizing everything else and making it easy and creating this infrastructure that's cool and really, really efficient, including especially power and memory usage.
Yeah. Well, that is kind of the essence of the commercialization process, right? Is making things tuned, efficiently, optimizing for power, optimizing for cost, optimizing for stability, supportability. That's kind of the essence. And so I think what you're saying is that, a more standard NPU architecture at the edge would make everyone's life easier. Although my counterpoint is, we're still innovating. And maybe there's, maybe there's frontiers out there we haven't found yet. Talking about efficiency is kind of the new frontier for AI. And, we saw it with DeepSeek models and other things like that, where, we're still at like I said, the steam engine era of efficiency. If the human brain is operating at 20 watts, the equivalent nuclear powered multi-tenant data center is operating at, 200 gigawatts or whatever. We're orders of magnitude away from being efficient with AI. So is it too early to close the door on kind of radical new hardware architectures that could get us much more efficient? I guess, Reza, what you're saying is, like, on the data center side, yeah, sure. But I don't know, like maybe on the edge too. I don't know.
I think, definitely no. I mean, no one should claim that there will be no new innovation coming, but
I mean, we're not done yet, I think.
No, we are not. I mean, we're not done. I think the question is the next for a few years, how everything is going to evolve.
Yeah.
For sure. And definitely in the resource constrained systems where NPU is one of 50 functions, a few things become important. I mean, we have customers who want to run a good workload of AI, but they want to run in a small device on a battery that absolutely have to at least last 7 days before a recharge, right? That becomes all of a sudden a primary constraint. Memory size become a constraint because the model has to fit, but memory got to be inside the chip. Otherwise, there's a lot of power to go and fish data every time out of cycle, lots of external memory. But I think there's another thing, which probably is what you're alluding to, is like everything else, NPU architecture is going to evolve. It'll be Gen 1, Gen 2, Gen 3, Gen 4. So it got to be entities which have that ability to constantly evolve the NPU architecture, but yet keep a certain level of backward compatibility in place, which to me is critical. This is eventually becomes an architecture that becomes one of the ones that become standardized. And while you do that, you got to spend a lot of R&D on it. And yet you have to have the return on the investment for the R&D. And to me, the way it works is you got to be able to provide that IP as an IP to multiple different users. Otherwise, if you end up to be a single user that have to evolve the NPU and make it backward compatible, eventually the model financially may kind of run out of steam. So hopefully we'll see the next few years what architectures are the winners, hopefully one or two max. And around it is very nice framework and a tool chain. And then there's, and then the users can start using devices which become easier to use as they evolve their own evolution of.
Yeah, no, I see that. I think there is definitely a path here for a lot of the mainstream use cases to use a more standardized architecture, no question. And that's going to accelerate, and build like an ecosystem of application developers and things like that. And so that's a piece. But I'm also interested in seeing like where some of the disruptive architectures could go to. And, disruptive architectures by definition are high risk, high reward type things, of which, we'll see how it plays out. But we got a few minutes left, so maybe we can do some. What is your closing words of wisdom here to help people figure out how to close this gap? How's this gap going to get closed?
I'll let Reza answer it first, maybe.
I think technology has a way of working itself out, so we'll see how it develops. But I should say, I think what you Pete is doing at AGI Foundation is an important part of this standardization, in my opinion, because you're developing a community for AGI. These are scientists and engineers from different companies, universities, hobbyists. So I think AGI Foundation as a whole could be a driving force in creating that standardization to enable evolution of the endpoint AI, sharing of information, sharing of models, public, So I think you could be yourself and your foundation can be a very important part of this evolution and standardization. So
good.
Well, you're 100%
on that. Cool. Rajesh, what are your closing thoughts on this hot topic?
I totally agree, right? You have to have an ecosystem.
Right.
And the ecosystem has to be well established. And that's why we want to seriously contribute through Model Nova and through AGI Labs to make sure that there is resources available for everybody to go learn about this and accelerate product to market.
Right.
So as a result, Model Nova Fusion Studio, some of the things that we are working towards and working with you, Pete, I believe, I seriously believe that we can make a huge impact for our customers. But at the end of the day, it all boils down to one thing: show me the money, right?
True.
We still need to be cognizant of the fact that, this monetization model is built in play, so everybody gets to benefit from it.
No, you're right. Yeah, and I think collaboration is key in this space, and finding those points of commonality and standardization, whatever the word is, where we're going to sort of rally around some of those things to really accelerate the market is key. Because at the end of the day, you're right. If we accelerate the market, then people can, monetize that market, hire more people, pay more people, do more things, expand. and we don't get too wrapped up around the axle on kind of esoteric engineering work, which is fun, but not always profitable. Yeah, I really appreciate both of you, coming on the podcast today. I think this was a really important kind of existential conversation that we struggle with in this space. And, it's great to be in the middle of all this innovation that's happening. And I think, speaking of the good old days, I think these are the good old days, by the way. So we will look back on these days as the days before whatever comes next. So thanks again, both. And I hope to see you both soon. Rajesh, I guess I'll see you in Milan.
Yeah.
Reza, I'm not sure if you're in Milan. I think one of your folks.
No, you see one of my colleagues there. So
there you go. Okay, so you'll be there in spirit. Well, we'll get you a hat.
Always.
Sounds good. All right. Talk to you both soon.
Thank you.
Thank you.